And so when you have this, it's probably a good idea to put letters, add letters to it. So A, B, and C perhaps, right, to these corners. And for now, we're going to ignore the overhang for now. Okay, I'm going to worry about that later, because if I find the length from here to C, I will just add the 1 to my answer later on. So right now, I'm just going to focus on this length. Do you have a pair? Yes, right? But can I move forward? Do I have enough information to move forward? I don't. What could I do? Richard. That's right. So what Richard is referring to is that if these two sides are the same, then we know that the angles opposite to them are also the same, the base angles in this case. So angle B is going to be found by going 180 minus the 70 up here, and that is going to be split in half. That, like, whatever's left over when you subtract the 70, you will split evenly amongst the two remaining angles. So that's 110 divided by 2, that's 55. Angle B is 55. Angle C is also 55. Right? They're both the same. So really, it's your choice what you want to do. If you find one side, you'll find the other. There's no need to do this twice, right? So the fact that this is an isosceles triangle gives you a lot more than what you're thinking, right? So I will start with my pair here. Sine of 70 degrees over 36 feet is equal to, which 55 should I pick? Funny. Sine of 55 over, well, let's say I'm trying to find side C, and then you cross multiply and divide. So that is 36 times sine of 55 divided by 30, by sine of 70, sorry. I have no idea what the answer is. So you're going to have to tell me if I get this right. I get 31.38 feet. So rafter is going to be 31.38 feet plus the 1 foot, right? So that will technically be 32.38 feet. And we're supposed to round to the nearest foot, right? So we would say 32 feet. Is that what the answer is? I hope so. Anyways, that's how you do it. I'm just quickly going to give it a question 5. Oh, it says 32 feet. Oh, it says to nearest inch. Okay, got it. So this is in feet. Now is where chapter 8 comes in handy. That's where that comes in handy. So 32.38 feet. I obviously have 32 feet, but I want to know how many inches, right? So I take this. Technically, I should be taking all of it. 0.3820 feet, right, times 1 foot has 12 inches. Cancel that. So when I have my answer there, I take away the 31 from that answer, and I will just multiply that by 12. That's 4.58. inches, which is approximately 5 inches. So my answer is 32 feet 5 inches, which is what the textbook, I thought I read it wrong. I thought it said to nearest foot. So you have to convert, right? Good? All right. Any questions? No questions? Do you have any answers? No answers? Okay. All right. Cosine law. All right. Recall that angle, angle, side, angle, and side, side, angle. They all have a pair, which means use sine law. Oh, could you solve, maybe I'll leave that for after cosine law. Two other cases you may encounter would be when you know all three sides. Okay, this is called, we call this SSS. Okay, or side, angle, side. And I think I'm guilty of always making the diagram look like that. How about underneath, we'll just do one of these. Side, angle, side. Right? So it doesn't matter, like if you have that situation where you have, I think of it this way, this one has the two sides, right? And the angle is in between those two sides that you're given. That's SAS, right? And side, 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 you just cannot miss that one, right? That's the a dead giveaway. It's like that's cosine law guaranteed. Notice that neither case has a pair. Like you cannot get a pair out of that. Nothing that you can do to get a pair. Okay. These cases we do not have a pair, comma, which means we have to use cosine law. So we'll do them separately because they look different. Okay. SAS case. And we're gonna draw our triangle again, because we're going to base our formulas on this. And I don't necessarily like to always use ABC, so I'm going to use XYZ. Because otherwise students think it has to be ABC, and that's not nearly the case. If you ever get a word problem and you need to draw your triangle, put letters, like add letters to it, assign letters. Don't be scared to do that. Okay, so that means that this is lowercase y, lowercase x, and this is lowercase c. Just write it a little smaller. And if you have a different color pen or a marker, maybe I would encourage you to do that. You don't have to. But let's say in this particular case, I'm going to focus in on x. So side x is there, angle x is right there. Okay. So you would have, you would have these two sides known, and there's your letter, your capital X and your lowercase. Okay. You would have to start your formula like this. Cosine law states that if you take the side you want, in this case it's x squared. I'm going to make that, put that down in red. So if that's the side you want, then you take the squares of the other two sides. I meant to say XYZ, I went XYC, even better. C squared plus y squared. This looks like Pythagorean theorem, doesn't it? But it's going to look vastly different. Minus 2 times one of the sides here, C, times y, times cosine of that angle that's across the one you're trying to find. So that's when I'm going to use my red again and make a capital X there. So that's how you would write it out. If what you were trying to find is that side, then the angle has to be opposite to it, right? So let's pretend like, for instance, it's a scenario where we're trying to find side C. Then you would start with that letter, and then you would say equals. Now you're going to focus on the other two sides. So that'll be x squared plus y squared minus 2 times x times y times cosine of what? X, y, it has to be c. That's very important, because some students will just grab any random angle and just throw it in there. It's like, well, ask yourself, is it across the side you're trying to find, right? And then the last one is we need to write y. That's correct. So y squared is equal to, just think of the other two, right? C squared plus x squared. The order doesn't really matter as long as you have those on the other side, minus 2 times c times x times cosine of capital Y. If I were you on my study sheet, I would only add one of these. I'd only, like, I'm just showing you how the pattern, how it's different depending on where you're at on that triangle. But I would just say if you have one, you should be able to see that pattern over and over. So just tell yourself, or write this diagram with one of these, you should be fine. Okay. And then the other case, the SSS case. And I will add here one of of these. You need to find an angle, right? You already know three sides. All that is left to do now is try to find an angle that is missing. Okay. Sorry, it's going to move a little bit there. And so this is how you do it. Let's say I wanted to solve for angle x here. So I'm basing it on this diagram still. I would go like this. Cosine of angle x, and I'm going to make that in a different color. I would start with saying, hey, I want to find this angle. Cosine x is equal to, watch this. It's I have rewritten these formulas here, these equations. So I make a long line like this. And I'm going to go c squared plus y squared. Now I'm using my other color, minus x squared. I will use that color for the minus there and for the letter itself. And notice that they're opposite each other. And then the denominator, you go 2 times c times y. That would allow you to find cosine, or x. Right? Next is cosine of, let's go in the order we did before. Let's say you wanted to find angle C here. So cosine of C is going to be found by, what am I going to make sure I have on the end here? Minus side C squared, right? Got to make sure that happens. And the other two, so if you look at side C on my triangle, it's the x and the y. Those are the two sides that I'm going to go over and put here. X squared plus y squared minus c squared. And in the denominator, I go 2 times x times y. Notice that the c, side C, only shows up once. It doesn't show up anywhere else. Right? That's why I use a different color so it really stands out. And remember, it doesn't matter if you go y squared plus x squared, it wouldn't matter. As long as you have minus c squared, because this is the side that's across the angle you're trying to find. Last one, cosine of angle y. It's very important that you understand the pattern. If you understand the pattern, solving is a lot easier. So I'm going to make sure that minus y squared shows up down here, which means I cannot use side y anywhere. So I have to use side c and side x. So I have to go c squared plus x squared minus y squared. And then the denominator is 2 times c times x. And there are your formulas, okay? And I will add a note here for this. This is the one you need to watch out for. If the numerator is negative, comma, you will get an obtuse angle. That's very important. Do not drop negatives. If you end up with a negative, sorry, can't see that. If you plug in these values and you end up with a negative in the numerator, don't despair, don't dismay. It's there for a reason. Your calculator is going to give you an obtuse angle. You know what obtuse is, right? Greater than 90. So it might be 91, but it's still obtuse, right? Might be 90, right? Like just over 90, but it will be obtuse. All right, so again, I would say on your study sheet to not use up too much space, because we all know we need space, right? I would just have one of each with a different color so that it kind of stands out. That's why I highlighted X, because I kind of just, I'm thinking you should just focus on the one version of this and then the rest should be fine. Okay, now that we know the formulas, we can actually solve some questions here. Yep. Okay. SAS. Solving for an unknown side. We'll just move this up here a bit. None of my triangles are ever drawn to scale. You probably noticed that already. And I will tell you that this is 8 centimeters. This is 5 centimeters. And let's say that this particular question is asking to solve for side D. So you should recognize that there are two sides here given and the angle between, right? This is an SAS. I can also say that there's no pair. That's another way of looking at it. So you have to use cosine law. So just for this example, I'm going to actually label all the sides. I'm going to call this capital E here. So this is technically lowercase e, and this is lowercase f right there. Okay. So technically, if I wanted to solve for side D, I would say d squared, always squared, is equal to f squared plus e squared minus 2 times, I'm going to just use dots, okay, like that. I hope you've seen that before. I know you have. Times cosine of, I'm solving for side D, so I better have angle D across from it like that. That's basically what the cosine law. And the other one I gave you is basically just this one rewritten, okay? So D squared is equal to, let's plug in, 5 squared. We're using easy numbers right now. Times 5 times 8 times cosine of 70. My next line is D is equal to square root, because you need to square root, just like Pythagorean theorem. If there's something squared, you need to square root it. So grab your calculator and see if you can type that in. You should be able to type that in one shot. So 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 70. And I get 61.638, and that keeps on going. We're going to use all decimals there. Take the square root of it, second x2, right? Go copy that answer. And my side is 7.85. What are we, centimeters? Yeah, we're in centimeters. Oops. Not too bad, right? Do you have a pair now? Yes, I do. I do, right? I just found this side. So could you switch over to sine law now and keep going with sine law if you wanted to? Yep. Will you get the same answer regardless? Yes. Okay. So that's the beauty of this. I will make a note here. Notice that you now have a pair, comma, so you could use sine law to solve the triangle. So if they asked you to solve for all sides, all angles, you could now actually, it's your choice. But at the beginning, you only have one. Make no mistake, at the beginning, you only have one. You will not be able to use either or to start off. Go ahead. So I'll get you to try one. We're going to call this, I'm going to go X, Y, Z. 13 inches, 26.7 inches. Solve for Go ahead, try it before I move on to the other case. So you don't really need to write out the formula every time. I'm just doing that for you. Just show me how you substitute, right? So if you're trying to solve for that side, you would just say, right, automatically. Oh boy. Let's try it again. Okay, so here I'm curious to see if you got this part right. So you're supposed to get 997.06. It keeps going. And when you take the root, you get 31.58, which is what I expected. I expected something that is longer than 26.7. I will just make you aware of something if you're doing this in steps. Can you just type in cosine of 103? What do you get? negative value. If you were to take the inverse cosine, so go second cos of the previous answer, what should you be getting? You should go back to 103, right? So that's what I was trying to say earlier. If you were to take the inverse of cosine to get your angle, you will get an obtuse angle. It also goes for if you're trying to find the ratio of an obtuse, you will get a negative. So what happens here is that this negative will meet this negative at some point when you multiply this out, and it actually turns this whole expression positive. So it ends up being this plus this whole thing. Okay? What's that? Ask. What's that? I typed it wrong. Cosine of 103? You're not getting this? Oh, this here. This part is not. Okay, hold on. Every once in a while, you know, it happens. I did that. 2 times 13 is 26. I just do that. Oh. What? Okay. Correction. This is what you get, right? I don't know what happened there. Oh, I know what happened. I changed the numbers on you from this one. I give you, yeah, okay. My bad. Square root of this one. That's what I get for going off script. Is that what you get? Okay. 32.22. Sorry. Messing up your notes. I'll fix that later. But now let's get back to this note that cosine of obtuse will always give you a negative 0 point something, right? Negative ratio, okay? So cosine of 103 is actually negative 0.224, and that keeps going, right? So if you don't type it in one shot, you might have issues there. Thanks for letting me know. Appreciate that. Don't want to confuse you. It's the last thing I want. Okay, next. Okay, here we have this case. Finding angles using cosine law. Example. Determine the measure of the largest angle. triangle XYZ, where x is equal to 3.1 centimeters, y is equal to 2.8 centimeters, z is equal to 2.4. So not even a diagram given, right? But you should recognize, like, all I have is sides. This is, right, side, side, side. Cannot use sine law. It's going to be cosine law. And the nice thing about cosine law is the formulas are completely different. If you're trying to find the angle, it's going to look as follows. So what I'm going to do is I'm going to give myself a diagram to go by. X, Y, Z. And then I'm just going to go ahead and write the numbers in. And knowing that, right, side Y is across angle Y. And so forth. Where would the largest angle be located? You're saying X? Yeah, because it's across the longest side, right? Angle X is across longest side. Therefore, angle X is the largest angle. Just a little note, right? And because this is somewhat new, I'm going to say if I want to find this angle happens to be X, it could be anything, right? I'm going to start with cosine. I know it's cosine because it's side, side, side of that angle is going to be equal to, this is side X, this is side Y, this is side Z. So what is going to be at the end here? You're going to have a minus x squared, correct? So that means that the other two sides are going to be here. So this is z squared plus y squared minus x squared over 2 times z times y. So that's the formula that I looked up on my study sheet and said, okay, how can I make this work, right? So I'm going to now plug in cosine of x, which I don't know what it is going to be z squared, 2.4 that is, plus the other side squared minus the 3.1 squared. All of that is going to be over 2 times 2.4 times 2.8. To save some space, we're going to do this. We're going to go equals right next to it because it's accurate to say. We will first type in the top. Do not do this whole thing at once. Let's type in the top number or numbers and see what we get. Okay, so 2.4 squared plus 2.8 squared. And you're going to beat me, I know that, because you're so good at texting. 3.99 is what I get on at the top there. And the bottom is 2 times 2.4 times 2.8. So notice that the top is positive. I'm going to get an acute angle, not an obtuse, right? Just make a note of that. So this is 13.44. So this is going to be optional later on. So technically you do this, you substitute, you give me that. To get angle x, I'm going to have to take the inverse of cosine of that. Do not round here. Do not round. Use 4 decimals if you have to. Most of the time 4 will be enough. Angle X is, get your calculator, you go second cosine 3.99 divided by 13.44. So watch how I type that in. I go inverse bracket 3.99 divided 1344, close bracket, hit enter. It's 72.73. Sometimes I will ask you to round to the whole nearest, right? To the nearest degree. But for now, that's what it is. You now have a pair. Yay! If you like sine law, you can now go back to sine law. Okay. And now we're going to do one example where we solve the triangle where I show you how we mix it up. Okay. So you can technically, if you remove this, you could do 1, 2, 3 lines and you're done, right? Solve the following triangle. I will just make a note here. If given a choice, always, right, solve for largest angle first. So if you're given one of these where it's like, hey, solve a triangle. The reason this is because if you want to switch over to sine law, there's a bit of a problem if you don't first take care of the largest angle. So you need to take care of the largest angle first. If given a choice, if I tell you, hey, just solve for this one angle here, then you just go straight to that angle and solve it. But if I tell you solve a triangle, basically giving you a choice how you want to proceed, then you need to go do that. So we draw our triangle, make sure they don't look like right triangles, right? And you start on one corner and move over clockwise. That's what I tend to do. This is 7.8 inches. This is 4.4 here. And this is 7. Make sure you put them in the right place. Side, side, side. Cosine law. Not even a question. That's the one that's the easiest to identify. Which angle is the largest? F, right? So I'm going to go cosine of F is equal to, so I kind of blocked this off for now, and I'm just go 7 squared plus 4.4 squared minus 7.8 squared. Make sure you square them all at the top. Some common mistake is students multiply the whole thing. This times this times this. I can tell you you're going to get an error later when you're trying to find your angle, so you know you've made a mistake. 2 times 7 times 4.4. Let's go ahead and find what that is right next to it. So that's 49 plus 4.4 squared minus 7.8 squared, 7.52. And then we have 14 times 4.4. So that's the first line there. Angle F is cosine inverse of that. And the last one is just using the inverse, and it's 82.99. So one down, right? You got this angle down here. I'm writing it in with a different color. Okay. Have a pair. I choose to switch to sine law. This is just because I want to show you how it's done. If you want to stick with cosine law throughout the whole process, go for it, because you can go everywhere. You can go all corners and just repeat this step one more time, and once you have two angles, you can easily find the third. So I'm going to go sine of 82.99 over the side that's across from it. And that is equal to, which one do you want to find next? That's up to you. You want to find angle N? Is that what we want to do? Okay. Unanimously agree to solve for angle N. And then we put the 7 inches here. And we cross multiply and divide. So sine of N is 7 times 82.99. Oh, what's wrong with that? Can't do that. Can't do that. You just can't. Divided by 7.8. You know what? Why not? Let's go right beside it. 7 times sine of 82.99 divided by 7.8. 0.8907. And so then angle N, sine inverse of that, take the inverse of sine. That's the one thing you need to watch out, because you're going to be so used to using cosine law, all of a sudden it's sine. So you will write down that this is what you did, but in your calculator you actually wrote down inverse cosine, so you have to be careful. 62.96. Almost done. Angle U is 180 minus angle F minus angle N. I don't expect you to do this. I just show me the numbers you're subtracting. And because now I've solved for all angles, all sides. Homework, page 137 in the textbook, 2 to 8 and 11. Is there a word problem in there? Yes, there is. I'll let you struggle with that one. It's a good one to try. Struggling a little bit is part of the process. Okay, so what I will do is, because I'm assuming you didn't bring your textbooks, right? You didn't bring them? Yeah. I told you not to bring them, right? I will just put this up on the screen, and then you can just do your homework in class. How's that? And then we'll start board problems tomorrow. Okay. Starts at 2 there. I don't know if you want to take a picture with your phones, but I'm going to leave it there for a while. So. This is on page 137, so if you